use Euclid division lemma to show that square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. Okay, so we are looking at this scenario. So let's understand the question itself. What are they talking about? They're talking about square of any positive integer. So the basic idea here is we need to take a number, we need to square it, and then divide the square number, divide the square number by 3 and check out that the results will be either 3m or 3m plus 1. Okay, so this is the basic idea, right? So let's get a different perspective, actually same perspective with using different method. That is, let's look at our coding and try it out. So the same HCF coding, right? But here the divisor is what? 3. First thing, the start and the end number, we can change it 500 to 541. But the difference is this other set of numbers. I need to consider the remainder when we square them. To do that, I need to actually square them. So where do I do that? Well, over here, right? I put 2 stars and 2. This indicates that I have to square this set of numbers. And what are this set of numbers? 500 to 540. Okay. So again, this section of the presentation, I will be explaining it in a different platform altogether, different video altogether. So let me not discuss too much, but what I just did was I squared it, and the remainder on that is being found. Okay, so that's what you need to understand. I took the number, I squared it, and we'll find the remainder. Actually, I already found the remainder, and this is to present the given situation. So we are presenting, and we can clearly see we have the pattern. Okay, so let's understand this pattern. Now, so the heading will be remainder of square of numbers, right, on dividing with 3. So that's your heading. Okay, so we have set of numbers, right? So this has been this have been squared, and squared numbers have been divided with 3. So you can clearly see the remainders are 0, 1, 1, 0, 1, 1, 0, 1, 1. It's kind of weird, is it not? That, at least you should have got 0, 1, 2 or some kind of 2 somewhere. But no, the number are telling that it will be always either 0 or 1. That's what your question talks about. So to verify this, let's change the number. Let's make it some easy number, 6 to 47, that is till 46, right? I know I take extra number, why is it so, and all of that you'll understand in coding. So let's look at the graph. I need to look at the second graph, right? 6 to 46. Okay, so 6 square obviously is divisible by 3, so we get a remainder of 0. But 7 square, we are getting a remainder of 1. So let us do this mathematically as well. Not programming, we'll do it manually. So we're taking the number 6, same procedure. I'm squaring it, 36, and 36 divided by 3. I'm getting 3 into some quotient, in this case 12. Right, now let's look at 7. 49. When I divide 49 by 3, right, I'll be getting 1 and 16. 16 3s are 48, right? 16 into q, sorry, not 16, 3 into q, but is 16 in this case, plus 1, the remainder will be 1, is it not? So the next number 8, 64 divided by 3, I'm getting 31, okay, again 3 into 31 plus 1, right? You can see the pattern. Next number is 9, so obviously 9 is divisible by 3, so you'll get 3 into q, is it not? So let me convert this to q. So 9, 10, 11, 12, 13, 14, so on and so forth. So you can see that pattern here as well. So this pattern is what they want us to prove, right? So let's do that. So what should we use? What is the method that we have to use? We have to use as per Euclid division lemma, right? If A and B, where A is greater than B, are all positive integers, then we have A is equal to BQ plus R, where R is greater than or equal to 0 but lesser than B, and where Q and R are unique positive integer. This is something which we need to write all the time, so there is no escape. Now let's substitute. B is equal to, what should I substitute? The divisor is 3, is it not? So your statement will change to A is equal to 3q plus R, where R is between 0 and 3, right? This implies R is equal to 0 or 1 or 2. Okay. Now we are looking at this particular equation, but A represents a positive integer, not the square of it. So what should I do? We will square both sides, right? I'm squaring this equation, but condition will not change. See, the condition is 0 and 3, that we can't square as such. The condition will not change. I'm just taking this equation and squaring. The condition it changes actually, but we can't square it, so we're just squaring the equation. So we have A square is equal to 3q plus R the whole square. So what is the formula which we are using? A plus B the whole square is equal to A square plus 2AB plus B square. A small note, if you want to understand identities and stuff, I have a basic video, please do watch that, right? So your A square will be 3q the whole square plus 2 into 3q into R plus R square. So we need to solve this a bit. See, all the basics, whatever you see over here, I have taught it in basics, so please do watch it. 3q square is 9q square plus 6qr plus R square, right? So now I have a few things common in the first and the second term. Can you guess what is that? 3. So 9 and 6, we have 3q square plus 2qr plus R square. So this is equal to 3m plus R square, where m is 3q square plus 2qr, right? Yeah, any confusion? If so, do let us know. We will make it a lot more clear. So this is a bit of math which I did so as to make our solution a lot simpler. So still we have not yet got the final answer. We showed that the square of number can be expressed as 3m plus r square. But you have to show that it will be either 3m plus 0, if not 3m plus 1. Okay, so we have to take different cases when the remainder is 0. So a square will be 3m plus 0. So one question, the first part is done. Okay, so I don't have space, so I'm writing it over here. A square will be equal to 3m. So we showed that yes, one of the set of numbers will have a presentation which will be 3m, right? Like 6 square, 9 square, and all of those group is 3m. Case when the remainder is 1, you have a square is equal to 3m plus 1 square, which is 1 itself. So we just showed that the second group is already in the form of 3m plus 1. Now the last group 2, so a square is equal to 3m plus 2 square, which is nothing but 3m plus 4. So I can always write 4 as 3m plus 3 plus 1, which in turn I'll take common 3 plus 1 plus 1, and I'm going to call m plus 1 as n, right, where n is m plus 1. So the main thing is pattern: 3 into some quotient plus 1, 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 and 3 into something, and again 3 into something. The pattern is important. Don't think about the variables. You can always use any variable you want. Okay, I happen to use m over here. I could have used n also, or p also, whatever you guys want, right? So this is how you do the question. Now I hope it's simple, and I hope you understood the question as well. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification and calculation, DIY projects. We'll code with Python, we'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. There are printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.